Hi everyone, welcome. We are so excited to have you here as you start your journey towards New York City Specialized High School Admissions Test SHSAT. In this video, we're covering a math lesson to build the foundation you'll be needing to get a top score. Before we begin, be sure to have a pen and notebook ready with you because we'll be talking about many tips and strategies throughout, so make sure that you do have all of the necessary equipments so that you can note down anything that you find important. Also, if you cannot afford expensive tuitions, don't worry. Our free lessons and practices are more than enough to help you prepare completely for your exam. Plus, our app also offers a predictive test, which is going to give you a realistic feel of what the exam is going to feel like. Now, let's get started and take the first step towards landing into one of New York City's specialized high schools. So like I said before, if you would want more practice materials, make sure to download our SHSAT Prep app from Apple App Store, where you are going to find lots of different practice materials so that you do not need expensive tutoring anymore. Without any further ado, let's get ahead with the video.
So in this lesson, we're going to learn about prime numbers, even and odd integers. Integers are whole numbers. Let's just get that clearly. Positive and negative integers, factors and multiples, at the same time GCF and LCM. So let's see what either of these topics really mean. Let's look at the first question, okay? What is the sum of all distinct prime factors of 323? So first of all, what are prime factors? Prime numbers are basically the numbers that are divided by the number itself or with 1. Let's say 2. 2 can be divided with 2 itself. Just 2 divided by 2 is 1, and 2 can also be divided by 1 because any number in this entire world generally gets divided by 1, right? So that are prime numbers. But when we consider factors are the numbers that you use that to completely divide any number. Let's say if we look at 4, the factors of 4 are 1, 2 and 4 itself. Why? Because 1 times 4 is 4, 2 times 2 is 4. So that is 1, 2 and 4. Do we have any other numbers that completely divide 4? No, right? So in this case, they are asking for, first of all, we need to figure out the prime factors of 323. Then we need to add them, all right? So first of all, let's notice something. Like if I consider 20 times 20, what that really results is in 400, right? So that means that if we want to consider 323, which is less than 400, at least one of the factors of 323 must be less than 20. Right? So that means that if we consider odd numbers, let's say if we consider 3, 7, I'm just going to write it down so that you do know what I'm thinking about. 3, 7, 11, 13, not 15 because that goes with 5. Like as in all the multiples of 15 give off a number that ends with 5. So again, we can consider 17, 19. Like these are some numbers that must be a factor of 323, right? Okay. Now, if we look at these, let's say in situations like this, what we now have to do is individually we have to divide 323 by each of these factors. So if we do 323 over 3, what that gives us is we can even do this mentally on our own because 3 with 3 goes and then you have 2. So that's a 0 and then you have 23. So can we ever divide 23 with 3? No, right? Now if we look at 7, if we do 323 here and if we put a 7 here, 7 times 4 is 28. 29, 30, 31, 32. So that's 43 and we know 43 and 7 does not go. Then if we look at 11, if we remember 11 times table is very easy because 11 times 2 is 22, 11 times 3 is 33 and so on. So there's no way it's ever going to be 323. If we do 323 with 13, let's see, because 13 times 2 is 26. So 26, 27, 28, 29, 30, 31, 32. So that gives me 63. And then if we want to do 13 divided by, if we look at 13 times 4, was 13 times 4? That's 3 times 4 is 12. Carry the 1. 4 times 1 is 5. 5 and 1 is 6. So that's 62. So of course, because 13 times 4 is 62, that does not give me 63. That does not give me a remainder, so that does not go with 323 again. Let's now look at 17. If you do 17 with 323, as we know, 17 times 2 is 34. So we need to do 17 times 1 is 17. So that gives me 19, right? So that's the 193 here. And now if we want to, let's say 32 minus 17 was, 32 minus 17 was 153, my bad. I'm fixing it. So that was 153. So let's see, do we get anything if we do 153 over 17? Let's look at 17 times 9. Because 17 times 10 is 17 itself. So 17 times 9 is, 9 times 7 is 63. Carry the 6. 9 times 1 is 9. 9 plus 6 is, yeah. Finally, we do get it, right? 17 times 19 is 323. Okay, I did write a lot. Okay, I hope it's not too overwhelming. I'm erasing this for you so that you do understand. Like, let's have some more space for us to do the remaining. So as we can see here, 17 times 1 gave us, 17 times 9 gave us 153. And with that being said, 17 times 19 is 323, right? So now we can say 323 is 17 times 19. Of course, both of these are different prime factors. Distinct means, by the way, it's different. So if had it been 17 times 17, our answer would not have been correct. So now we need to know the sum of them. So sum of these prime factors, which means you do 17 plus 19, which gives us as 36. So 36 is your final answer. I think we took a long time with this math, but I hope that you finally understood how to do this. Let's move on. How many distinct pairs of the first 5 prime numbers have an odd product? So what are the first 5 prime numbers? 1 is not a prime number, okay? So we start with 2. Then we have 3, not 4, 5, not 6, 7, not 8 or 9 or 10, but 11. So these are the first 5 prime numbers. So how many distinct pairs have an odd number? So the product of 2 odd numbers is always an odd number, okay? So any odd number that you have times another odd number that you have is always going to be an odd number. You can try it out first. Sorry for that. You can also try it out for yourself. Like if you do 3 times 5, that's an odd number. 5 times 7, 35, that's an odd number. So any number, odd with odd, is always an odd number. So what are the possible pairs? So here, can you do 2? No. If you do 2 with any of these numbers, it's not going to be an odd number. So let's just cancel out 2 here. So all you now do is, you can now do 3 times 5, that's a pair. You can do 3 times 7, that's a pair. 3 times 11, that's a pair. Now we're done with 3. We can now do 5 times 3, which is already done. So we don't repeat. We do 5 times 7 and we do 5 times 11. Okay, done. Now if we look at 7 only, 7 times 3 is already given. 7 times 5 is already there. We do 7 times 11. And for 11, there's none remaining. So how many pairs are there? 1, 2, 3, 4, 5, 6. So there are 6 distinct pairs of the first prime numbers that have an odd product. Okay, let's move on. The sum of all digits of a number is 273. That number is always divisible by which prime number? Okay, so first of all, what you do is, if the sum of all digits of a number is divisible by 3, that means that number is also divisible by 3. Okay, so that means that if this is the sum, right? This is the sum. So if this is divisible by 3, the answer that comes out should also be divisible by 3. So first of all, let's do 273 divided by 3. Okay, let's just do this here. It's kind of easy because 3 times 9 is 27 and then 3 times 1 is 3, right? So let's just write it. So it's 91. So therefore, this number 91 should also be divisible by 3, right? So this is one of the ways in which you can just write that, therefore, the number is divisible by 3. It's always divisible by the same number. Let's look at another example, because you might be thinking that, okay, it's divisible by 3 in this case, but does this apply every time? So let's look at another number. Let's look at 348. So the question said the sum of all digits of a number first. So the digits here are 3, 4, and 8. If we add 3 digits up, what do we get? We have 3 and 4 as 7, 7 and 8 as 15. So once again, the sum of 3, 4, and 8 gives us what? It gives us a number which is divisible by 3, right? So since 348, as in the sum, got divisible by 3, we can also say 15 by 3, which is 5. So that means 15 is also divisible by 3. So the answer to this is, the number is always divisible by which prime number? It's always divisible by 3. Okay? So I also added an example so that you do understand that properly. If you do, make sure to do this practice question. You can take a screenshot of this. You can pause the video, try doing this on your own. And I hope that you do get this correct answer. The answer is already written here. Moving on. Here we have a and b are positive integers and ab plus a is odd. Reina concluded that a and b must be odd. Is she correct? First of all, there are some things that you do need to remember. If we have an odd number with an odd number, the answer is always even. An odd number with an even number, the answer is always odd. And an even number with an even number is always even. So these are the 3 things that you do need to remember for this practice, okay? Even if you don't remember these, it's totally fine, because you can make up these numbers on your head. You can try to figure out a couple of examples on your own, and you're good to go, okay? So because the question says AB plus A is odd, that means either one of them should be odd. Either AB should be odd or A should be odd, right? But if both of them are odd, the answer is going to be even. So no, both of them cannot be odd. One of them should be odd. Again, if we go for multiplication, odd times odd gives me an odd number. Even times even gives me an even number. Odd times even gives me an even number, okay? So now that we know that, since we know that an even number and an odd number gives me an even number, so if we say that A is odd and B is odd, let's say A is odd, yeah? And if B is odd, so odd and odd gives me an odd number, right? So if A is odd and B is odd, then AB has to be even. Because if I consider A to be odd here, so entire AB cannot again be odd. So that means if A has to be odd, then AB has to be even. That means according to this question, B cannot be odd. So B must be even. I hope this totally, concludes everything. If you do want another example, I can give it to you. So in questions like this, you can actually take separate numbers. So you can say that let A be odd. So if A is odd, let A be 3. So in that case, if A is 3, of course, the entirety of AB has to be an even number, right? Because as we already know that either AB or A has to be odd. So if A is 3 and AB has to be even, and once again, from A and B, if A here is 3 again, if it's odd again, then can B again be odd? No, because if you do 3 times any of the odd numbers, it's obviously gonna be ending up with an odd number. So what you do here is you need to put an even number for B, so that if you multiply that to 3 or with any other odd number, it makes AB into an even number. I hope that makes sense. So that means B has to be an even number and A has to be an odd number. So is she correct? No, she's not correct. Okay? Also take a screenshot of this or note these down with the additions and the multiplications. Okay? Moving on. So we have an example here. Set A contains all positive odd numbers. Okay. Set B contains all factors of 33. So let's just write down what set B contains. Factors of 33 are what? 1 can be divided with anything. 33 can be divided with 3, and then 11, because 3 times 11 is 33, and the number 33 itself. So these are the factors of 33. Set C contains all prime numbers. Okay, how many numbers belong to all three sets? Okay, so if you look at 1, 3, 11, and 33, out of all four of these numbers, how many are positive odd numbers? These are all positive numbers, right? So these are all positive numbers, and if you consider odd numbers, all four of these are odd numbers. But set C says that it contains all prime numbers. So from 1, 3, 11, and 33, how many numbers are really prime? Is 1 a prime? No. 1 looks like a prime number, but 1 is not a prime number. So in that case, my numbers are 3, 11. Is 33 a prime? No, because 33 gets divided with 3 and 11, also with 1 and 33. So that does not mean it's a prime number. So finally, my numbers are 3 and 11. So how many numbers are there? There are 2 numbers who belong to all 3 sets. Okay. Here's another practice question. Try this on your own. I hope you do get answer D. Moving on. The sum of 6 different positive integers is 90. If the smallest of these integers is 10, what is the largest possible value of the integers? Okay, if the sum of 6 different positive integers is 90 and out of them the smallest number is 10, one of the integers has to be the largest, the other has to be the smallest. So let's say, because these are 6 different positive integers, we can consider them to be consecutive. Why? Because they're saying that if they're smallest or if they're the largest. So let's say the numbers are starting with 10, because 10 being the smallest, it can be 10, 11, 12, 13, 14. Yeah? So the smallest 5 integers can be 10, 11, 12, 13, 14. However, it did ask for the largest number. So the largest number can be what? The largest number can be God knows what. Why? Because it did not give us a final limit. So if the smallest 5 integers are this, for sure, what is the sum of these 5 numbers? So let's just figure out the sum. Yeah, let's just figure out their addition. So to add them up, do you know what I'm going to do? I'm going to do a short mental math practice. So you can do, because all 5 of these numbers must have a 10 with them. So I'm just going to do 10 plus 10 plus 10 plus 10 plus 10, which gives me a 50. And with 11, there's an extra 1. With 12, there's an extra 2. 13 has an extra 3. 14 has an extra 4. So it's just 50 plus 1, 2, 3, 4. So 4 and 3 is 7. 7 and 1 is 8. 8 and 2 is 10. 10 and 50 is 60. So the sum of all of these numbers is 60. So that means the sum of the first 5 numbers is 60. But if you add all 6 of these numbers, you're going to get what? 90. So that means till the first 5 numbers, the sum of the first 5 numbers plus the 6th number is going to be 90, right? So if you want to know the 6th number, the largest number will be 60 minus 90, which is 30. So 30 is your final answer. Okay? This was quite interesting, most definitely. Let's move on. If the product of the integers p, q, r is 1, what's the smallest possible value of the sum of p, q, and r? Okay. So if p, q, r is 1, let's just assume some numbers, okay? Let's say p is 1, as in p is a positive number. And even if q and r are negative numbers, it's also going to be equals to 1. You know why? Because negative and negative makes positive, and positive is positive. So 1 times negative 1 is negative 1. Negative 1 times negative 1 is again positive 1. So that means if the numbers are like this, what is the sum of p, q, and r? So the sum is basically 1 plus minus 1 plus minus 1. So that's just 1 minus 1 minus 1, right? 1 minus 1 is 0. 0 minus 1 is minus 1. So minus 1 is your final answer. Okay, moving on. Here we have a practice question. I hope you do get minus 10. Let's see the next one. When k is divided by 4, the remainder is 2. What is the remainder when 3k minus 1 is divided by 4? Okay, this is an interesting question. There's one particular format that you do need to remember. So whenever you find remainders, and of course if the remainder is positive, to understand what you would get if you divide by 4 with a remainder being 0, what we do is we take the divisor, which is k, and then we take the remainder and we put a minus in the middle. You try it out for anything, okay? Let's say if you divide 5 with 2, you get what? You get 1 as a remainder, because 2 times 2 is 4, and then it's a 1 as a remainder. So in that case, had you not divided 5 with 2, had you divided 5 minus 1 with 2, which is what? 4. If you divided 4 with 2, you would not get any remainders, right? So that's basically a short, you can say it's a formula, it's a method. So what I do is I take the divisor, I take the remainder, and if the remainder is positive, I'm going to put a negative sign in the middle. So that means if k minus 2 is divided by 4, you are going to get a 0 remainder, okay? It's going to be a 0 remainder. All right. So what's the remainder when 3k minus 1 is divided by 4? So first of all, let's just do, what do I get if I do 3k minus 2 divided by 4? So if I do that, of course, that means if k minus 2 is divisible by 4, then 3 times k minus 2 is also divided by 4. 100 times k minus 2 is also divided by 4, because in that case, you're just going to cut the k minus 2 and k minus 2 out, and you're going to be ending up with the answer, right? So what is 3k minus 2? If I break it down, that is 3k minus 3 times 2 is 6. But the question said, what do I get if I do 3k minus 1? Okay, so if I do that, that means if I have 3k minus 6, and on the other hand, if I have 3k minus 2 as divisible by 4, let's just put a plus 4 here. Why? Because 3k minus 6 plus 4 is what gives you 3k minus 2. So my main factor here is to convert that to 3k minus 1, right? So now if I want to convert 3k minus 2 plus 1 as divided by 4, the remainder is going to be 1. So if it's 3k minus 2 plus 1, that ends up as 3k minus 1, which gives us a remainder of 1. So my final answer to this is, it's a 1 as a remainder. Okay? Moving on to the next question. When an integer n is divided by 6, the remainder is 2. When n is divided by 7, the remainder is 3. If n is greater than 50 but less than 90, okay. So we need to know the numbers between 50 and 90 that are also divided by 6 and also divided by 7. So we need to know what? The numbers between 50 and 90. So first of all, let's look at the numbers that are multiples of 6, as in they are divided by 6 first. So multiples of 6 that are essentially between 50 and 90. What are they? So 54, and then 60, 66. You can just do plus 6 and move on. So that's 72, 78, 84, and 90 itself. If I consider multiples of 7, let's now take multiples of 7 between 50 and 90. So it's 56, because 7 times 8 is 56. And 63, 70, 77, and 84. We don't have any other numbers. Okay. Now, because when you divide it with 6, the remainder is 2. So do you remember what we do? We do plus 2. So we do plus 2 with these numbers. So that gives me what? That gives me 56, 62, 68, 74, 80, 86, and 90 is now 92, but we're not going to write it because that is more than 90. And same thing with this, because it gives me a remainder of 3 here, so I'm going to do plus 3. So 56 plus 3 is 59, 66, 73, 80, and 87. Okay. Now, what is the possible value for n? So what is the number that has, it's like common in both? We have 56, 62. See, if you look at these two pairs of numbers, what do we find common? We have 80 common, right? So what is the possible value for n? A possible value for n can be 80. Okay, let's look at the next question. So we have a practice question here. Hope you do get 5 as the answer. Let's move on. All right, now we have greatest common factors, okay? So for greatest common factors, what you do is you first of all try to divide 420 and 1290 individually. So let's do that. Let's divide it with 2 first. So when you divide these numbers, try to take all prime numbers and take the smallest prime numbers. So you know you can divide 2 with both of these numbers. So let's start with 420. It's going to be 2 here. So that's 2 times 2 is 4, 2 times 1 is 2, and then a 0. And then you can again take 2. 2 times 1 is 2. Then 0, and then 5. So that's 105. Of course, you cannot continue with 2 anymore, but you can continue with 5 for sure. So 5 times 2 and 5 times 1. Now you can do 3 and 7. Okay. How about 1290? So let's start with 2. 2 times 6 is 12. 2 times 4 is 8. 1 and 0. So it's 5. So now you can take 5. 5 times 1. 1 and 4. So 5, 2. 4 and 5. 5, 9. Okay. So now you have 129. Interesting number, because what goes with 129? Can 3 go with 129? Yeah, 3 times 4 and 3 times 3. And 43 is a number that you cannot simplify furthermore because 43 is a prime number. So now let's just write the numbers down for 420. So you have 2 and 2 and 5 and 3 and 7. For 1290, you have 2 and 5 and 3 and 43. So to figure out the greatest common factor, you can actually circle the numbers that you find common. So here we have 2, and then here we have 5, and here we have 3. We don't have any other number common, right? 2 times 5 is 10, 10 and 3 is 30. So your final answer is 30. Okay? Next, let's move on. So what's the greatest common factor of these 3 numbers? Do it on your own. It's quite simple. Answer is going to be 6. All right. So now let's look at what's the least common multiple. Just like we have done already, okay? If you want to, because the numbers here are quite small, right? The numbers are not so big. So I think we can do them manually on our own. Because if you want to divide 6, it's just 2 and 3. If you want to divide 9, that's 3 and 3. If you want to divide 18, that's 2 with 9. And in the case of 9, you can write 3 and 3. So for least common multiple, what you do here is, first of all, you write down what's common. So what's common here is 3, right? And now what? Now, if you look at the numbers, you have a 2 here on this row. So how many 2s do you have? You have 1, 2, and 1, 3. How many 3s do you have? You have 2 3s. How many numbers do you have? You have 2, and then you have 3 squared. So the first thing is you keep the number that's already common. When that is done, out of the numbers that are left, what's the highest power? The highest power, as we can see here, is once again, it's 3 squared and 3 squared. There's another number here. That means we need to put a 3 squared as it is. And also, what's the number that's remaining? The remaining number here is 2. So for least common multiple, what you do here is you are going to look at the numbers individually. So there are only 2 numbers, 2 and 3. And then you're going to look at what their powers are. The highest power of 2 is 2 itself. So that means we're only going to write 2. And the highest power of 3 is 3 squared. You may say that, okay, it's not 3 squared in the first row. Doesn't matter, okay? So when we look at least common multiples, it doesn't matter. It doesn't matter how many numbers are common or anything. Had it been greatest common factors, the answer would have been 3. But for least common multiple, that's not what we do. We only look at the powers. So 3 squared is 9. 9 times 2 is 18. Okay? All right, moving on. I don't think we have much left. Here's another LCM. Okay. Let's look at this one. This looks like this is a word problem, but of course we need to know if it's the greatest common factor or the lowest common multiple, the least common multiple. So let's see. A straight stick will be used to measure a rod of exactly 816 feet, which is multiple of the size of the stick. Okay, the same stick will be used in the same way to measure another rod of exactly 546 feet. So what we know for sure is 816 and 546 will now need to be broken down like this, right? And because the question said was the longest stick, of course, we now need to figure out the greatest common factor. Why? Because longest, greatest, they all go together. So basically, they're asking for the longest or the greatest common factor. So first of all, let's break it down. Let's use 2. 2 times 4, and then 2 times 0. 2 8s are 16. 2 2 0 4. 2 1 0 2. 2 51. Now you can use 3. 3 times 1 is 3. 21, so that's 17. And no, 17 is a prime number. You cannot divide anything with 17. Moving on to 546, that's 2. 2 2s are 4. 1 and 4, so that's 7. And then you have 3. 273 can be broken down with 3, right? So if you use 3, 3 times 9 is 27. 3 times 1. Again, you can use 3 for 91. Wait, can you use 3? No, I think you can use 13. Because 13 times 7 is 91. That's it. So now if you write them down, for 816, you have 2, 2, 2, 2, and 3. For 546, you have 2, 3, 13, and 7. So obviously, you have 2 and you have 3 as common. So it's 2 and 3, which is 6. So 6 feet is the longest stick that can be used for both of the measurements. The circumferences of 3 wheels are 12 inches, 16 inches, and 20 inches. For sure, we know we need to break 12, 16, and 20 down first. And then a point P is marked on the 3 wheels. What's the greatest number of complete revolutions? So for greatest number of complete revolutions, what do? We most definitely need to see was the greatest number of complete revolutions made by the smallest wheel when the point P on each wheel comes to the starting position again for the first time. If we just look at the name greatest, we would have thought that maybe we need to know the greatest common factor. However, the question said that made by the smallest wheel. So because there's an additional information here with the smallest wheel also there, so that means we need to know the lowest common multiple, okay? So you need to read the entire question before you come to a conclusion. And because the numbers are small here, let's not manually break them down. Let's do it in our head. What's 12? 12 can be 2 times 6. So 6 is 2 and 3. What's 16? 16 is 2 times 8. So 8 is 2 times 4. 4 is 2 times 2. What's 20? 20 is 2 times 10. 10 is 2 times 5. If you write them down, you can write it's 2 squared into 3. This is 2 to the power 4. And this is 2 squared into 5. So do you remember what I told you for LCM? What we do is we take into the numbers. So how many numbers are there? We have 2, 3, and 5. What's the highest power of 2? We have 2 squared, 4, and 2. So the highest power is 4. And then what's the highest power of 3? There's just only one 3. So you put 3 as it is. What's the highest power of 5? You put 5 as it is, okay? So that gives me what? So 2 to the power 4 is 16. 16 times 3 times 5. So 16 times 15. That gives me 240. That's not my answer because the greatest number of complete revolutions made by the smallest wheel. The smallest wheel has how many inches? That's 12 inches. So the smallest wheel is going to have 240 divided by 12. So 12 times 2 is 24 and then it's just a 0. So the final answer to this is 20. I think we are down to probably the last question here. Our floor measure is 90 feet long and 74 feet wide. What's the greatest side of square that can be used to cover the floor without cutting any tile? All right. So I'm just gonna draw this so that you do understand. So it's 90 feet here and 74 feet here. So the question said that there has to be square tiles in the middle. So how many square tiles? So what's the greatest side of square tiles? Because the square tiles can even be like 1 centimeter or 1 inch long or 1 feet long. So what's the greatest number of square tiles that you can use to cover the entire floor? So once again, the greatest, right? So greatest means greatest common factor. So individually, I can do 90 and 74 here. Let me just erase this part here so that there's space for me to figure out the greatest common factor for 90 and 74, yeah? So if I do 90 here, it's 2 and 45. Now I can take 5. So that's 5 and 9. And then that's 3 and 3. So for 90, that's 2, 5, 3 and 3. Now let's do 74. Let's do 2 first. So that's 2 times 3 is 6. 2 sevens are 14. 30s. Wait, did I do it correctly? 2 times 37. Yeah. And then if I look at 37, what can 37 really get divided with? Wait, 37 is a prime number. It doesn't get divided with anything. So it's just 2 times 37. So what's the greatest common factor? The greatest common factor here is, if you want to look at the values, is just 2. So the greatest common factor to this is 2 feet. Okay. And now if we look at this question here, we have another practice question. Find the smallest positive integer divisible by each of the integers from 3 to 7, including. All right. So once again, you do this on your own. I hope that you do get 420. Here we have another practice question. I hope that you do get 4 laps as well.
So with that being said, that is the end of this lesson. Thank you so much for watching. And if you want more practice materials and videos like this, make sure to download our SHSAT Prep app from Apple App Store. You are going to find out a lot of practice materials, and at the same time, there's a predictive test waiting for you so that it's going to give you a real feel of what the exam is going to feel like. Thank you so much for watching once again. Make sure to check out our next lessons, and at the same time, subscribe to our YouTube channel for more.